Anyway, so just globally welcome everyone. It's great to see this kind of an interest in our curbside chats. And just to go over a few things, I'm going to close that down.
Okay.
A quick agenda. We're going to start with the presentation, as you all know, and I'm pretty sure that's what's interested you all today and had you come out. We after that presentation, we'll do a quick Q&A on the topic. And then we're going to open up for the rest of the time to talk about anything that you might have on your mind, any questions you have about industry issues that are going on. Maybe somebody has an answer for you or some suggestions, anything you have for the CPA. So we'll just do an informal networking at the end of that. I just want to let everybody know that this session is being recorded. So beware of that. So no swearing or, make sure you have pants on if you're going to stand up and all those things, okay? And we do appreciate if you put your face on so we can see who you are. It's hard enough to get to know new members and new attendees anyway, notwithstanding being on these video chats. So if you're got your hair done and you're feeling a bit showy today, let's see you. Put a smile on your face and come on and join us. That being said, I'm going to get started and introduce our speakers. The company, founded in 2014, is headquartered in Waterloo, Ontario. 11X offers solutions that focus on solving specific areas of need. Led by a team of world-class authorities with extensive knowledge of wireless technology and a passion for helping organizations, 11X is ready to provide a solution that's right for your needs. The CPA is pleased to have 11X as our very first sponsor of the Curbside Chat, so we thank you very much for that. And as I said, looks like you've attracted quite a few people who are interested in your topic. So without further ado, please welcome Dan Mathers, President and CEO of 11X, who will present innovation as driving stall-based occupancy monitoring. So take it away, Dan.
Fabulous. Let me just share my screen here. Hopefully everyone can see that. Everyone see it?
Mm-hmm.
Awesome. Excellent. All right. Well, good afternoon. Thanks a lot, everyone, for the opportunity to talk with you all today for this Curbside Chat. Very exciting topic. My name is Dan Mathers, as I said, and I'm President and CEO of 11X. We're a technology company, and one of our major focus areas is on smart parking, not only for the municipal market, but also for the enterprise markets. Today, just if you were to think about all the topics we could talk about, I mean, certainly we could talk about, the state of COVID and the latest news, but far more exciting topic is getting to talk to you today about really one of my favorite topics, which is innovation in the parking industry. It touches everyone. And, so there is nothing better than, being able to talk about, the current state of the market, and how we can improve things, not only to make it better for each of us as individuals, but also for cities and businesses in terms of improving parking situation, driving real ROI, both social and financial. When you think about this, we really are firm believers that stall-based occupancy is key to delivering a lot of the benefits of smart parking, and that innovation is really driving this stall-based occupancy. When you go down that journey and down that path to arrive at true smart parking, it's the data, the stall-based occupancy data, and specifically real-time stall data, that is one of the key elements that really determines the quality of the solutions and whether or not they deliver value and promise. People are people are people. If you end up using a system or experiencing a system and it's wrong or it's unreliable or it's turned off because it's down or whatever reason that is, you stop using it, you stop paying attention to it. And as as somebody running a municipality or a business, you rely on high quality data to be able to make the right decisions. Otherwise, you might make the wrong decisions. So while there's a myriad of technologies out there that are all trying to provide the right data, in the long run, it's widely agreed that sensors provide the best approach in terms of accuracy, cost, integration potential, et cetera, and of course life cycle, because once you put a system in, you want it to last for a very long time. New innovations have advanced sensor technology. I'm going to talk a little bit about that today, while bringing costs down and therefore further enhancing the value proposition. Now, just go to the next slide here. I want to use, there's been lots of parking studies done. There was one done in LA, there was one done in Washington, DC. This particular one, which I'm sure many of you have heard about, was done in San Francisco. I want to use the San Francisco pilot as a basis to talk about kind of then versus now, the benefits that can be realized from taking this type of approach, the types of sensors that can improve not only your compliance, your enforcement, but also wayfinding, guidance, navigation, supporting dynamic pricing programs, all of these things integrating with other technologies to drive a better experience, more revenues at a very, very low cost-effective price. So the SF Park pilot project, done in 2011, 18,000 stalls. They were monitored for several years. And really, they were looking for improving parking through data-driven solutions. And I mentioned a few of these previously: wayfinding, guidance, dynamic pricing, compliance. It was very, very innovative for the time. Very early days as well for sensor technologies. But in spite of all that, they got amazing results, and I'll talk about that. But the the average rate fee, parking fee, was reduced, but overall revenue was increased. There was higher availability of stalls, higher payment compliance. In addition, people reduced the search time, reduced cruising time, which reduced congestion, and of course, reducing GHD, and overall resulted in safer streets and a better experience. Now, these were dramatic improvements and dramatic outcomes. So why didn't it proceed? Well, basically one of the foundational technologies here is stall sensors. And, in this case, they had used a variety of different sensors from a variety of different vendors with different accuracy, reliability, cost. And while the state of the technology at that point was in the very early stages, it delivered significant benefits. But because it was in its early stages, it really was very expensive. I think the pilot cost something like $25 million, 80% funded by the federal government. And the life of the sensors was short, really only 2 to 3 years. So it really makes ROI challenging. But this has now changed, and that's the message today for this curbside chat. It's possible to get cost-effective sensors that are accurate reliability with a lifetime that are greater than 10 years, and that are very, very provide ongoing value for this sort of thing, such as the sensor that 11X provides. And there's others out there in the market that also provide these sensors. So why even think about doing things differently, right? And to us, it's all about optimization. So generally, the industry's been doing things the same way for a long time. We do, parking studies once a year, once every 2 years, send people out to count cars and count spaces. Generally, the recommendations are pretty similar. You want to, if you have occupancy greater than 85%, you got a real problem. You end up with gridlock. If you, a lot of people, lots of studies have said people are circling for parking in the downtown core, and the BIAs are all over this and saying, hey, can't find parking. 17% of people in some communities, studies I've seen, they just go home, they don't buy anything. Right? And so that's bad for everyone. Everyone gets frustrated. People, other issues, people a lot of people don't pay for parking. So We know that 70% of people on average pay for parking, 30% of people don't. So if you could improve compliance, you can improve revenue generation and for the city. But overall, you want to not only do that, but you also want to have happier residents and citizens, and that's what I think the promise of this technology is. So how do we achieve all of this? To achieve these goals, it really takes innovative thinking. Um, Again, you could do a parking study, but this changes on a daily basis, right? With weather, construction, seasonality. I know in the city of Stratford near here and city of Niagara on the Lake, they're very driven. Like, let's just take Stratford, who has installed our solution there. They go from a population of 35,000 people in the wintertime to 150,000 people who come there for the Stratford Festival. And people are driving around trying to find parking, and depending on the time of day, whether there's a show on at 1, 2, or 3 of the different festival theaters, whether it's the weekend and people are visiting because it's a nice day, it changes constantly, right? So this concept and challenge of demand versus supply can really be addressed in a lot of different ways. But often without the data, cities really only are left with a couple of options. And sometimes that decision is to build a parking garage, which is obviously very, very expensive. Other solutions to manage this, like dynamic pricing, like improved compliance, wayfinding, you really need the stall-based sensors to be able to drive that. And so we give more tools to cities and enterprises to manage the situation. There's lots and lots of technologies out there, and you are all familiar with many of these. And I'm sure some of the folks on the phone, and I know Blake, as a video-based solution, and they're all very, very good solutions, right? Like from a mobile payment standpoint, again, we know about Honk, we know about Hotspot, we know about Smarking. There's many out there, and some of them claim to give you stall-based occupancy, but just remember that 70% of people pay and 30% don't, but it's an average. So on any given day, it might maybe 50% of the people paid, maybe 90% of the people paid, maybe 100% of the people paid. So you really can't infer with any sort of accuracy how many stalls are available through your mobile parking app, and you certainly can't get down to the granularity of an individual stall. Video is very, very good as well. Video can be very, very accurate under ideal conditions, but when there's snow and wind and rain and the lens gets dirty and all sorts of other things, it can have its limitations and be less accurate. In addition, great for surface lots, maybe not as great. In fact, probably not great for on-street parking. And there's always a mix of these solutions out there for on-street versus surface lot. And in addition, you get blockage with things like trees.
Hi, Mom. She had to go to.
I think somebody may not be on mute. And then LPR, again, this is good for indoor, right? Where your license plate recognition, you're going into a parking garage and just taking a snapshot and trying to basically match up, reduce the occupancy by 1. These generally are pretty accurate. They're 97% accurate. If you got a high volume parking garage, your counts are going to get out pretty quickly, and you got to go and do manual audits. And it's not really appropriate for on-street occupancy. But again, a great technology, and it has its place. But we think that stall sensors, and it's widely acknowledged that stall sensors, if you want the best option for accuracy and for reliability, to give you the data that you need, stall sensors is the best. Now, sometimes we'll combine stall sensors, and other companies as well will combine stall sensors with other technologies. For instance, we have partnerships with MyStall for some implementations, combining our stall sensors with video. From a common denominator standpoint, there's always a stall sensors involved to get that accuracy. So I want to move on and just talk a little bit about advances in sensor technology. There have been some incredible advances in technology in the last 10 years. And it's amazing really what a $1 microprocessor can give you. There's entire industries of people, not just parking, that have been driving smaller, faster, cheaper, lower power solutions in terms of microprocessors. And there's also been a lot of innovation across the other elements of the industry. For example, wireless technologies, the radio, the battery technologies to get long life. Inside these parking sensors, they include all of these technologies in addition to radar and magnetics, at least in the instance of the 11X solution. Sometimes it's magnetics alone, sometimes it's a combination of other technologies that really allow for a cost reduced installed in-ground sensor. And just to talk a little bit about wireless, why is it important for wireless? Well, you don't want to go digging up pavement and infrastructure to be running cables and power everywhere. These sensors, think in Canada, we have snow plows, they have to be buried in the ground. So you really need something that's going to last on batteries for a long period of time. So one of the things that some of you may or may not know about is the LoRaWAN technology. And this is a global wireless standard. It's been deployed everywhere in Europe, relatively new to North America. Our company and a number of other companies provide that LoRaWAN network. Google supports it, Microsoft, Cisco, all of the big players, IBM. And the technology, wireless technology, has specifically been designed for these type of applications where, is there a car there or is there not a car there? And so it's a very small amount of data blipped out on an event basis whenever the state changes. And so the parking industry really has been a big beneficiary of these technology advances over the last 10 years. So again, a lot of these technology advancements in the Internet of Things have been incorporated into sensors and wireless technologies and all the other technology solutions really that I showed earlier on in that slide deck. You can now get a sensor for less than $100. They go 10 years on batteries. That's one of the key characteristics of LoRaWAN, is that batteries last 10 years, very reliable and highly accurate. And so that opens up a whole bunch of things because now you can get reliable, accurate data over a long period of time. It's really, I want to talk a little bit about the quality measurements. There's lots of ways to measure things. You can stick a person with a clicker on a street corner, not terribly accurate, but it's a way of doing it, right? And a lot of these things you can do parking studies, but if you really want to get accurate, reliable data at the right granularity, you need to be able to looking at this at the stall basis. Why reliable? Well, you want to make sure there's, why accurate? You want to make sure there's minimal human interaction because that introduces inaccuracies. And you want to make sure that it's real time so that it's accurate, so that at any particular time what the data is and what the state is. So, timeliness is really important. And the accuracy of whether or not there's a car there is really important. You also want to make sure it's really reliable because only getting some of the data some of the time causes all sorts of issues, particularly for some of the use cases that we'll talk about in a minute. And then the granularity, a lot of technologies, you can figure out how many cars are in my parking lot, maybe from the, in-out technologies. But you don't necessarily know at each individual stall whether there's a car there or not. That's important for specialty stalls, such as accessibility stalls, special time limit stalls, 30-minute parking, 15-minute parking. It's important for a number of other, for instance, e-vehicle charging stations. So again, it's all about the data, sensing it, sending it to the cloud, and getting it into the software application. There's four kind of primary areas of use cases, I guess, that are really interesting. The first is data analytics. That's an example screenshot from the city of Stratford. And you can see that there's an indication in their downtown core of whether or not there's vehicle there or not. You get stats such as turnover stats, number of stalls that are vacant, number of stalls that are occupied, so you can get an occupancy percentage. You can understand average length of stay and really dig into the data so that as a city, you can figure out exactly what's happening with your parking asset, and you can go and figure out in the future what your parking needs are based on the demands. And again, this is no different than a parking study is done today, but it's dynamic. This is dynamic versus static. You can also look at wayfinding and guidance. I talked about Niagara on the Lake and some of these other areas that have very high influx of people. And as soon as you get above 85%, you end up with big issues. People start not bothering to try and park their car, even though there's probably a ton of parking a street or two over. But when they drive by the business that they want to go to, they can't find a parking spot and they just get frustrated. Or they're doing the park search, right? They're just driving around, cruising, trying to find a parking spot, creating accidents, creating congestion, driving greenhouse gases. I'm sure everyone's heard the numbers. We each drive 1,670 kilometers a year on average trying to find a parking spot. If you're in New York City, you spend 107 hours a year, or Toronto or one of those, that's days of your lives trying to find parking. So there's significant benefits to implementing this, both social and financial. Of course, directed enforcement and compliance. As soon as you have to write a ticket to somebody who hasn't parked, who hasn't paid, now you have to go and enforce that ticket in court. It's so expensive. I mean, you've lost once you've had to write that ticket. The secret is getting directed enforcement so that you can drive and prove compliance. If you're one of those people that never pays for your parking, you're in that 30%, you're probably never going to pay your parking ticket either, right? Until you get to court. But if I get a ticket every time I park in a spot and don't pay, I'm going to start paying in all likelihood. And so you do that by sending the enforcement officers heat maps to figure out where to go to get a high number of offenders, and so that you can ensure that offenders get ticketed all time, every time, and not rely on them just offending when you drive around in your LPR vehicle or chalking tires, which some communities still do. And then, of course, dynamic pricing is a staple of this. Not only raising your prices from $1.30 an hour to $1.50 an hour, given the number of parking hours in a year, makes a dramatic change. But also, if you make the pricing a little bit lower in the off streets and a little bit higher on the main streets, you'll guide people and can guide them to the lower parking. You'll end up with an overall better parking solution. So this is all about risk, right? There's a risk profile on all of this stuff. There's two areas of risk. One is cost, one is performance. And, I think that when you're thinking about these things, that's really what, you need to think about. How am I going to reduce the risk? What technologies am I going to use so that I get the right outcomes and for the right price? Just want to circle back for a minute to the SF Park study and just show, what they did is they basically had a control area and they had a pilot area. And they measured both on street and off street, like surface lots, etc. And what they did was they experimented with doing rate changes. And so you can see that the result in the on street versus the off street, and this is an average, so some went a lot lower and someone a lot higher. But the result of this was they generated $1.9 million more in revenues over the pilot period. And the reason why was a number of reasons. First of all, you got rid of the park search. I'm just going to give up and go home. So I'm going to actually park, but I'm going to park maybe in a less expensive area where there happen to be spots. And I'm also going to improve significantly my compliance. You can see that 23% fewer citations were issued as compared to the control group where it was 12%. So, it's the combination of those that really was a major driving factor in that. You can also look at, the data from a park search standpoint, 43% reduction. In the control group, it was 13%, so 30% decrease, and then reduction in daily greenhouse gases, which is significant. So when you look at something like this and what it can mean for your city, it really drives the point home that you get a better financial outcome, you get a better social outcome, you get happier citizens, more economic development, and why wouldn't you do it? Why wouldn't you do it? Well, one of the reasons why you might not do it is if the reward wasn't big enough. Right. And so what I did was I just wanted to talk a little bit about this for a minute. People all over really, and the reality is people are starting to adopt these data-driven solutions at a pretty high rate. The benefit once you get the data and get it reliably and get it at the stall level, you can do a whole bunch of things with that. And I'll just take you through a very small use case example from an ROI standpoint. This is basically a mid-sized city that we've based this use case on. So think of 1,861 municipal parking spaces, 1,574 surface lots, 287 on street. Pay periods are 8 to 6 p.m. Monday to Friday, $1.30 per hour average. And the total annual paid parking inventory, therefore, is about 4.8 million hours. Now, we've been very conservative, but in this use case study, but assume 50% are monthly permits for the sake of argument. And the utilization for all spaces during paid hours is 85%. That means that you've got an expected, annual paid hour inventory of about 2 million hours. Now, if you've got 70% compliance, you're only getting about 1.4 million hours paid. However, if you can improve that compliance to 90%, you can get those paid hours up to almost 1.9 million. And what that means is that you get an increased annual parking revenue of 535K. Now, the sensors in this particular case last 10 years plus. And so that's really key to this. And you can see how dramatic that is. Over 10 years, you generate with that improved compliance, just making people pay instead of having to go write tickets, of $5.4 million. Now, how much does all this cost? Well, in this particular instance, with real-time stall occupancies with sensors, advanced analytics, enforcement compliance, gateways, all in installation, network connectivity, software subscriptions, everywhere for 10 years, 10-year contract, it's about $624,000. So it pays back in just a little over a year and less than $400 a stall for a 10-year term. So pretty dramatic. And this is only, remember, there's 4 use cases, the data-driven analytics, the wayfinding with all of its benefits, and then, of course, targeted and directed compliance. And then the fourth one being dynamic pricing, which wasn't even factored into this use case. So in conclusion, I just want to say, first of all, thank you again for your time today. If our goal is as an industry to provide the best experience for the fairest price while making a healthy profit, stall-based monitoring data is really foundational to fuel all of these solutions. And with the current risk-reward profile, the time is now to go and innovate with stall-based sensors to deliver the data to really make the world better for all of us in terms of parking, which again touches all of us every day. So thank you very much. I'm happy to take any questions.
Don't be shy. Nothing? No questions?
I have one. Just sorry, this is Frank Cavalier talking. Just a point of clarity, the cost that you mentioned in the previous example for a 10-year contract, does that include the initial purchase price of the equipment?
Everything.
All in, okay.
Purchase price, installation, yeah, everything. I mean, of course, there's other things that you can purchase, like, extended warranties or maintenance contracts or that sort of stuff. But I mean, basically, this is all in. We have very high reliability on the sensors. They do last over 10 years, and this particular instance, the numbers are real. So.
Okay, thank you.
Hi everyone, Mark from 11X here. Dan, we've got one question in the chat and it looks like Alexis has her hand up. So why don't we deal with Alexis first and then we'll deal with the question that's in the chat.
Dan, it's Alexis from Western University. I just have a question about your sensors and basically how they handle the snow in the winter. Our snowplows on campus are notorious for being rough and
Yes.
they're not gentle on our lots, on our signs, on anything. And I don't want like a pile of sensors in the middle of the parking lot when the snow melts. So how do they hold up in the winter?
Yeah, so there's two versions of the sensor. They're really the same sensor, but just two different form factors. You see the one on the right there?
Yep.
That goes, you core a hole into the pavement. You basically go through the pavement to the base. You drop in the sensor, you cover it with epoxy, and then the snowplow can't get to it. So, we've had these out in the field for years, so no problem with that. The one you see to the left, the one with the black shell around it, that's a surface mount sensor. So you'd use those in communities where there aren't snowplows. But there, you might, the in-ground one is a little bit cheaper, so you might just use that one for all applications. But some parking garages, of course, have membranes and rebar, and so you don't want to be kind of coring into that. So that's why we have a surface mount version. It's just affixed with epoxy, so you don't have to drill into the membrane. So it goes in ground. Now, you raise an interesting question about snow and slush. One of the super big challenges is to get accuracy under all conditions. So is there water over the sensor? Is there snow over the sensor? Is there slush over the sensor? Is it a big truck or a little truck? Or, is there a plastic gas tank or no? I mean, there's tons and tons of technical effort and testing that needs to go into these to make sure that they're 100% accurate in all conditions. And so in this particular case, I mean, our team is very, very deep, technically speaking. Everyone's ex-BlackBerry engineers with 15 or 20 years of experience designing and developing low power wireless systems and defining algorithms to really optimize all conditions for these types of solutions. And so that's the situation. So these are really designed specifically for being Canadian, making sure that we address the realities of the Canadian environment, which actually are applicable in many other areas of the world as well.
Is there a level of snow, like a threshold that has to be maintained to be able for the sensor to be able to read? Because some days our ground screw does a great job, but there's sometimes, where the snow is just falling and you can't keep up.
Yeah,
Like
no,
how
great,
deep?
great question. So we've got, there's multiple technologies in there because you're hitting on a really key thing, if there's a ton of snow, will the radar not detect the vehicle? Will the magnetometer not detect the vehicle, or whatever other technologies are in people's sensors? So this likely wouldn't work if it was under the big pile of snow that they put actually haven't tested that condition, but you're not going to park a car over there either. However, under normal, use for snow, what do we get max sometimes a foot, a little bit more. Usually there's other traffic problems that are related to that than the parking occupancy. But in that particular, we've tested this under all typical conditions. So.
Okay. Was that good, Alexis? We'll move on, or do you have something else? Because I see your hands
Great. Nope,
up.
that's it. Thank you.
Okay.
Oh, I think it just.
Perfect.
There's another, we'll start to go to some of the questions that are in the chat right now. The first one up is, can I get the same level of data using just a payment app?
Yeah, no, payment apps are like, there's kind of, I call them like, there's good, better, best, right? So sure, you can try and infer data from a payment app, right? Because you get a payment app and that, X number of people paid for a day in this particular lot. And that you have so many spaces at any one time. And so therefore you can do a rough level calculation of how many cars are parked there. But it can be either accurate or inaccurate depending on the circumstances. So for example, I mentioned earlier, 30% of people don't pay. So you could just take the payment data and add 30% and say, okay, I'm good. But problem is that 70% of people who paid changes day over day, right? Sometimes actually hour over hour. Sometimes it's might be 30% of people paid. Sometimes it might be 90%. Sometimes it might be 60. On average, it's 70. So you don't really know the occupancy data there. The other thing is payment apps, generally you pay for your spot. What if you leave early? Your that spot would still show that it's being paid for that period of time, even though it was occupied. So you can actually generate more revenues by getting more granularity in the data and charging multiple times for the same spot. So yes, you can get the data. You can get an idea. It's a really good rough estimate. But it's, remember earlier I talked about the people experience. So let's say it's accurate that day and it says, well, there's one spot left in the lot, and you drive and you find that one spot and you go in to the spot and it's not there. There actually wasn't a vacant spot. How many more times do you think you're going to go and trust that system? So the whole thing kind of falls apart. It has to be pretty much 100% accurate in order for these systems to be used. On the data side, if you're telling people there's no spots in a lot, but really there's 10, 15, 20, you're not getting the other benefits of basically the wayfinding and guidance to navigation to be able to get people to their parking spots quickly. That 85% that I talked about earlier, that magic number, some communities bump up against that 85% occupancy number, and then you just get complete gridlock. What wayfinding and navigation does with by getting people to their parking spot quicker is it raises that 85% to a higher number. close to 90%. And then what you can do then is avoid building parking structures, because now it's magical. You kind of, created more capacity just by getting people off the streets and into parking spots by pointing them to where they go. Hopefully that answered the question. Guess I added some other stuff in there too.
Okay. We've got a couple of questions, Dan, and it's around the technology itself. So there was a question, the name of the technology and what it is, and it's called LoRaWAN, LoRaWAN, which is a low power technology, which is, we can go into more depth, but if you'd like, we could probably talk about that offline, going into serious technical depth, but really what that is it's just low power. And that's what gives us our 10-year life for what these sensors can do. And then there's a question from Jason that says, are the sensors compatible with all standard LoRaWAN network servers and gateways? So Dan, if you want to talk a little bit about, I guess, LoRaWAN and then the compatibility of our sensors.
Yeah, sure. Yeah. So thanks, Mark. Yeah. So LoRaWAN, like WAN stands for wide area network. LoRa is LoRa. It stands for long range. Some stall-based sensor technologies out there require you to kind of put a gateway. Gateway is basically a collector of data that then kind of sends that data to the cloud through, fiber or cellular or something. They require you to put one of those gateways for every sensor or two. LoRaWAN, what happens is LoRa stands for long range. So you kind of put one of these gateways up and it collects the data from many, many sensors. And so that, to give you an idea of long range in an urban environment, we're talking one gateway for 5 kilometers. So which covers most downtown cores. And they're very, very inexpensive. It's not like, hundreds of thousands of dollars for a cellular gateway. These things are, a couple of $1,000 each to put up. Anyway, so that's kind of one of the secrets to the economics. Another thing, they're purpose built for these applications that only have one blip of data, this of state change type things, right? The temperature is 32 degrees, there's a car parked here, etc. So yes, and it was designed as an international global standard. So any of these sensors can be put on any LoRaWAN network. Now, if you look at North America, we've got wireless FCC requirements and Industry Canada here, and they're different. ETSI in Europe, our sensors are designed to work on both, but you couldn't have one sensor that worked in Europe if you bought it for North America. But if you bought somebody else's sensor and put it on, that was designed for North America and put it on our network in North America, that would work. Or took our sensor and put it on somebody else's LoRaWAN network in North America, that would work, or in Europe. So it's a completely open standard, which is a significant benefit. It may not be of interest to this group fully, but like if you think about it, it's one network for many applications. LoRaWAN's also good for environmental, outdoor environmental air quality and other environmental factors such as flooding and manhole, storm sewer levels, indoor air quality for addressing issues related to COVID, and water metering, a bunch of other applications. And so cities like this because they can also use the same network for a lot of other applications.
Yeah, that's a great point, Dan. And I think we've also done installs where, because of the multi-network capabilities, we've also connected with waste disposal, so that they can track routes with that across campus, and as well with lighting, street lighting or campus lighting as well. So multiple purpose sort of with the network there. And as Dan said, you get the cost efficiencies. And there's also a follow-on question, Dan, about the sensor itself this time, and does it have dual support for cellular, Cat M1 or NB-IoT at this point?
Yeah, our sensor does not. There are other sensors out there that do. So, I don't necessarily want to make this all about, the 11X sensor. I'm really trying to talk about the industry as a whole. and sensing technology that might be applicable for your various applications. So yeah, there's we made our decision to take this approach based on what we thought was the best technology decisions. You can use cellular, you can use narrowband IoT, LTE-M, Cat-M, however you refer to it, 5G. They're all kind of part of the same standard right now. Part of the challenges that you just need to think about is, I know that with my cell phone, oftentimes, depending on where I am, I can't get a great signal. Think about then taking that and putting a big metal car over top of it. and whether or not there would be a strong reliability of getting a signal. And then also think about, like, LTE-M is now ubiquitous, but narrowband IoT still, doesn't have full coverage. I will say that our plans on our roadmap are to include those technologies in our future products, because we think, there are lots of use cases where that might be appropriate for the end application. And so we're a huge fan of cellular. We use, in fact, in all of our gateways or collectors where we collect all the data from the sensors, we get it to the cloud by backhauling with cellular. So, we use cellular as an integral part of our solution. And we have other solutions that aren't strictly parking related, that, as I said, we have on our roadmap to incorporate cellular into that, particularly a lot of the outdoor environmental monitoring applications. But yes, the quick answer is, no, we don't have it in our sensor. You can go and look at other sensors and judge the performance for yourself on whether it meets your needs.
Okay, and I think we've got a few minutes here, a couple more minutes. So there's a couple more questions. Sort of back to sensors, and Dan, when you were talking about structures and parking garages, and in the case, the question is, in the case of covered parking areas, such as parking structures or underground, can the sensors be mounted above the stalls and aimed downward? So I think you talked about the in-ground, but now they're talking about, can you have it sort of above and aimed down?
Right. Yep. Great question. No, today, all of our sensors are mounted under the vehicle. They are not mounted on the ceiling or on the post. However, that is something we're looking at. I know that some of the camera-based solutions and ultrasound-based solutions are able to be mounted over the vehicle. And in those cases, there's always trade-offs, right? Like you have to run conduit to each of those sensors in general. You have to run power to those sensors. And then you have to judge again whether the accuracy of those solutions meet your application need. As I said, there's good, better, best with all of these. There's a variety of solutions, and you really need to look at your use case. From our standpoint, stall-based sensing is the best is the best solution to deliver reliable, cost-effective data.
Okay, and I think we've got time for one more. And the question is, what if we're already using LPR? Will sensors provide ROI and value?
I always hate the "it depends" answer. If you want to give us a call after, we'll help you work through the details. It really depends on what you're trying to achieve. So if you are trying to, say, let's say you've got a parking garage that has 90%, let's say the LPR system is 97% accurate, right? Because maybe people have snow on their plates, or maybe they've got one of the Ontario plates where all the blue peeled off, or excuse me, whatever your situation is. If you had that, then your accuracy, you're going around and let's say you got 1,000 vehicles in and out, relatively low volume in a day, your count gets out of whack pretty quick. And so you can fix that. You can send people around doing manual counts all the time, or once a day, or once every 2 days, or once a week. But if you're trying to guide people into those parking garages, then what you really want to do is you want to make sure that there's accuracy of the number of spots, and also all the other benefits that I talked about. Now, maybe you just, and one of our partners takes this approach, and actually a lot of people take this approach. Maybe you don't really care about whether there's 100 spots or 90 spots or 80 spots. Maybe you just care about a rough indicator of, is there availability? And so, use a smiley face for yes, use a frowny face for no, and use a neutral face for in between. And if that meets your needs, then this might not provide value for that. But it really depends on the use case, is what I'm trying to say. And and I think a lot of us work together on the solution side. We have a partnership, as I mentioned earlier, with MyStall for TrueSense, which combines our technologies for certain applications. And it's really application based. So you let the application requirements and your objectives drive the solution.
Awesome. Well, I think that covers the questions that we had from the chat. I don't believe I see anybody's hand up. So Brenda, Patty, maybe at this point we'll turn it back to you guys, because we're getting pretty close to the 2 o'clock timing as well. So
unfortunately, we didn't have time for the open discussion. I apologize. Too many questions.
That's okay. There was lots of engagement, so that's really good. That's great. One thing that I took from it, from the perspective of the association, the very higher level aspect of this sort of technology and creativity and innovation, is that we're fighting the battle of the image all the time as the parking industry. And so when you can put these sorts of technologies together and introduce them and seamlessly let people come and go, they don't mind as much to pay, and they go a little easier on us as an industry when they're not stalled at a gate arm that won't open, or denied access for whatever reason. So kudos to you guys in the industry who bring that innovation, because it helps us to have a little bit of a better image with our community. So thanks for that. I appreciate it. And so do our members. So does anybody else, should we maybe move on to an open discussion? We have a few minutes, and we can take a few minutes for people who want to stick around. But before we do that, I just wanted to acknowledge that we had a few other board members. I'm not sure if they were on when I was scanning, but Ralph Bond, Sharon Lewinson, and Nigel Bullers were on our call as well. So I'd like to thank them for joining and supporting these activities as well. So, and then of course, Patty and Brenda, who do all the work, really. Thank you guys for putting all this together. So if anybody would like to pitch out a question or a topic that they might want to pose to the group, or put out there for people to think about, now's the time to do it. No? Everybody's so quiet. There's Nigel. I see your face now, Nigel. Good to see you.
Hey, Nigel. Good to see you again.
So that's it.
Good to see you, Dan. And that was a great presentation. So thanks so much for taking the time to do that. I really enjoyed it. We have a few folks on. I thought that was really informative, and you covered a lot of areas. I thought that was great.
Thank you very much. Appreciate it.
Yeah. Anybody else? No? You're all quiet today. The sun must be shining in your area. You want to get out of here. Anyways, I guess that's it for today then. We're going to certainly continue our curbside chats. They seem to be really popular. And just attendance today was great. So we really appreciate that. Don't forget to keep in mind our conference that's coming up in October in Vancouver. We're looking forward to seeing as many of you there as we possibly can. And we have a great show being prepared for you. So, so come on, one and all.
Fantastic. Thanks again, everyone. Really appreciate your time and the
Thanks.
opportunity to speak with you.
Thanks, Mark. Thanks, Dan.
Bye for now.
Thanks, everyone.
Bye.